to the concept of foot of the perpendicular and image of a point. Foot of perpendicular and image of a point on a line. Okay. Let me first explain to you what is the meaning of foot of the perpendicular and image of a point on a line. So let's say I have been given a line ax plus by plus c equal to 0. Okay. And I have a point with me whose coordinates are x1, y1. Okay. Now, foot of the perpendicular is basically when you drop a perpendicular from P onto this line, this point is called the foot of the perpendicular. So M is called the foot of the perpendicular. Okay. So the perpendicular that you drop from that given point onto the line, it is called the foot of the perpendicular. This is also sometimes called projection. This is also sometimes called projection of P on the line. Okay. Also written as projection of P on the line. Okay. Now, if you extend this further, okay, there would be a point, let's say Q, which would be at the same distance as P is from this given line. That means if you treat this as a mirror, plane mirror, okay, then Q will be like the image of the point P on that mirror. Okay. So Q is basically the image of the point on the line. Okay. Now, this is one of the favorite concepts of your school exams also. They will ask you what is the foot of the perpendicular and what is the image of a point, especially image questions comes a lot. So how do we normally deal with this question? So a normal approach, that means a school approach would be, to find, see, you already know this equation, right? Correct. So you know the slope of this given line. So you know the slope of PM also because PM is perpendicular. So if you know the slope of the line, you know the slope of the PM, which is the perpendicular to that line. And you know one of the points, which is P. So you get the equation of PM line and see where does PM line intersect the given line. That will give you M. Okay. Once you get M, in order to find Q, you will use the midpoint formula because M is the midpoint of P and Q. So if M is known, P is known, Q will also be known to you by the midpoint formula. Now, this approach may take a considerable amount of your time, right? Because you have to form the equation, you have to see the intersection of the equation with the given line, and you have to find M, and then you have to find out Q, right? So what I'm going to discuss now with you, how to directly get M and Q with half the time spent. Okay. So what I'm going to do is I'm going to give you a formula to get the coordinates of M and Q. So please make a note of this and then I'll prove it in the subsequent discussion. So coordinate of M can be obtained by use of this formula. Let's say this point is x2, y2. Okay. So x2 minus x1 by A is equal to y2 minus y1 by B is equal to negative ax1 by1 plus c by a square plus b square. So this formula is going to be helping you to get your x2 and y2. Okay, so you find your x2, y2 from this formula. x2, y2 from this formula. Okay, I will derive this result, don't worry. I'm not going to dump formulas on you without deriving it. So I never dump formulas on anybody without proving it. Okay, and let's say this coordinate is x3, y3. So Q formula for getting your x3, y3, you can use this formula x3 minus x1 by A, y3 minus y1 by B is equal to negative 2 ax1 by1 plus c by a square plus b square. Okay, I will prove this formula. So please first make a note of it. So from here you find your x3 and y3. Okay. Now, how do I come to these formulas? Okay, so these formulas are to be used only in competitive exams. So please use only in competitive exams. Okay, not to be used in school because probably your teachers may not be aware of these formulae. And whatever is beyond your NCRT textbook, it is, you are then at the mercy of the teacher. See, she may not give you marks. Okay, so please do not use any formula which is beyond your NCRT textbook without proving it. Okay, now from where do these formulas come? Let us try to understand this. First, copy down this. I'm going to the next page. Done? Copied? Okay. So let us derive the formula. So first we'll derive the foot of the perpendicular. Okay. So foot of the perpendicular, let's say I redraw the figure once again. This is my point P, which is x1, y1. Okay. And this line is ax plus by plus c equal to 0. So foot of the perpendicular is when you drop a perpendicular on this line. Okay. This is your foot of the perpendicular. Let me call it as x2, y2. Now to derive this formula, I will use an approach which is called the ratio proportion method. Ratio proportion method. Okay. Now I'll explain you this method. Okay. Now, first of all, can I say that the slope of PM into the slope of this line, which is minus a by b, will be equal to -1 because they are perpendicular. Okay. That means y2 minus y1 by x2 minus x1 is equal to b by a. Right? Slope of PM is given as y2 minus y1 by x2 minus x1. Correct? No doubt about this step. Now, I will rewrite this as x2 minus x1 by a is equal to y2 minus y1 by b. Okay, so what I did was I just took the x2 minus x1 term to the right hand side numerator and I brought the b down as a denominator to y2 minus y1. Okay, no doubt till this step. Okay. Now, next I'm going to do is I'm going to multiply this with an a and I'm going to multiply this with an b. Okay, remember while I'm doing it, I'm doing the same operation with both the numerator and denominators over here. So it is not going to change my given result. Okay. So in the left hand side, I multiplied numerator and denominator with an A. Right hand side, I multiplied numerator and denominator with a B. Okay. So prima facie, nothing has happened. Okay. It is the same expression as the step before it was. Okay. Now, something very interesting and something very trivial also. Okay, recall your ratio proportion days. I think in class 8th or 9th you would have done. If P by Q is equal to R by S, then remember this ratio is also equal to P plus R by Q plus S. Isn't it? Very obvious thing, right? So if 1 by 2 is equal to 2 by 4, then it is also equal to 1 plus 3 by 2 plus 4, which is same as half again. Yes or no? Yes, correct. So I'm going to make use of this in this particular expression. So treat it as if it is P by Q equal to R by S. So can I say this will also be equal to this by this? Correct? Okay. Any doubt here, please stop me. Any doubt, any concerns at this stage, please feel free to stop me. No doubts, no concerns? Okay. Now what I'm going to do is I'm going to pull back this A again, which I had put over here, and pull back this B again, which I had over here. Okay. Basically, I'm cancelling out the obvious terms. Okay. Now, what I'm going to do is, all of you please pay attention. I'm going to write this term as ax2 plus by2 minus ax1 minus by1 by a square plus b square. Okay, so I just opened the brackets on the numerator. I did nothing out of the box over here. So now what I'm going to do is, all of you please come back to this diagram. You all would realize that M should satisfy this line, isn't it? That means AX2 plus BY2 plus C would be equal to 0, isn't it? In other words, AX2 plus BY2 would be equal to negative C, correct? So what I'm going to do, come back to this step, I'm going to replace this with a negative C, right? Because we have just figured out that AX2 plus BY2 is negative C, correct? So when I do that, I end up seeing the formula that I had given you in the previous slide. So if you put a negative C, it becomes negative AX1 plus BY1 plus C by A square plus B square. Okay. This is how this formula is derived. Okay. This is to be used in competitive exams, and trust me, dear students, it is going to save a lot of time for you. Okay. So imagine you finding the perpendicular slope, you finding the equation of a line, you trying to find out the point of intersection by simultaneously solving it. This is a one-step, mechanism to get the work done. Let's take a simple illustration to understand how it works. So let's say I have a line given to me whose equation is x plus y plus 3 equal to 0. And there is a point 1, 1. Okay. I want to find out what is the foot of the perpendicular of this point on this line. Okay. I want to find the coordinates of M. So see, how do you apply this formula? So this point is x1, y1, and this point is x2, y2. Okay. So just follow your formula. This is your x1, y1, and this is your x2, y2. Okay. So now what are you going to do? You are going to do the formula. You're going to just apply the formula x2 minus 1 by A. Remember, A here is the coefficient of x in the line, so which is 1. Then y2 minus 1 by B, B is also 1, equal to negative of, you have to put this point over here. So when you put this point, you get 1 plus 1 plus 3 by A square B square. A square B square is 1 square plus 1 square, correct? So from here, you directly jump to the result, x2 minus 1 is equal to this expression. This expression is minus 5 by 2. Correct? So your x2 value will be minus 3 by 2. Okay, so this x coordinate is minus 3 by 2. Okay. Similarly, when you compare these two, you get y2 minus 1 is equal to minus 5 by 2. That means y2 value is also minus 3 by 2. So this point is also minus 3 by 2. Straight away, you got the answer without having to go through the hassle of finding the line, intersection point, etc., etc., etc. Is this fine? Okay, very useful formula. Please make a note of it. Now, in a similar way, we will derive the image of that point also by using the ratio proportion method. Again, let me tell you clearly, this formula itself is not there in your NCERT textbook, but yes, this concept is very much there in your school textbooks, okay, school problems. But refrain from using this formula directly in your school exams. Again, I am repeating it. Okay. All right. So now let us derive the image of a point formula. Image of a point formula. Okay. So image, let's say again, I take the line. Okay. I take a point P. Let's say I call it as x1, y1. And this time I'll call this image as x3, y3. Okay. One thing that you would notice is that this point M will be nothing but it is the midpoint of the P and its image. Correct. I'll come back to the use of this little later on. Now, let us again use the ratio proportion method. Ratio proportion method. Sorry. Let me switch off my camera. It is taking up the space. Yeah, ratio proportion method. Now again, the story is same. The slope of PQ into slope of this line is going to be -1, correct? That means y3 minus y1 by x3 minus x1 is equal to b by a. Nothing will change till that ratio proportion step. So x3 minus x1 by a is equal to y3 minus y1 by b. Okay, multiply this with an a, multiply this with an b. Okay, use the ratio proportion method. So this will be equal to a x3 minus x1 plus b y3 minus y1 upon a square plus b square. Okay, now all of you please pay attention at this step. This is an important step for us. I'll again cancel off the extra a's that I have, something like this. Okay, now here I'll write ax3 plus by3 minus ax1 minus by1 by a square plus b square. Now let us go back to the figure again. Let us go back to the figure again. We can see that m satisfies this line, correct? That means a x1 plus x3 by 2, b y1 plus y3 by 2 plus c should be 0. Okay, let us multiply with a 2 throughout. Let us multiply with a 2 throughout. Okay, so from here I can say that ax3 plus by3 is minus 2c minus ax1 minus by1. Can I say this? Okay, so what I'm going to do is come back to this line. This term ax3 plus by3, I'm going to replace it with this term. Okay, so when I do that, let me rephrase it. Let me rephrase it. Okay, so this will become minus 2c minus ax1 minus by1. Guys, just let me just close my windows. Outside, the children are making a lot of noise. Yeah, the Shara is coming now, so everybody is playing with those crackers and all those stuff. Now is it proper, Pranav? Can you hear me properly? Yeah. So yes, so I'm replacing this guy with minus 2c minus ax1 minus by1, and here also I already have minus ax1 minus by1 term present. Okay, so I can take 2 common because now I will have 2 ax1 and 2 by1 term also. So let me do that. Okay, so this will give me minus 2 ax1 plus by1 plus c by a square plus b square. And this is the formula that I had given you in the previous page. Okay, so this is true. So both the formulas are quite resembling. In one, you don't have this 2. In the foot of the perpendicular, this 2 is absent. And in the image, this 2 is present. Okay. Any questions here? Can you go to the left side? Okay, sure. Done, Hariharan? Let me know once you're done. Okay, great. Now, linked to this concept of distance of a point from a line, we already did the foot of the perpendicular coordinates. Okay. Now, we also did the image of a point on a line. Now, we'll talk about distance between two parallel lines.